Hey folks, it's Dr. Sweeney. What we're going to be looking at today is we're going to be looking at conic sections. We're going to be talking about how do we find the equation for one, how do we actually define them in terms of some very special ideas called the focus and the directrix. And then once we've actually found the equation for the parabola, how do we utilize that parabola in order to graph again? So that's what we're going to be focusing on. There are some side things that we're going to need to know about parabolas, and I'm going to have those show up inside of later videos. So let's start out with defining what a parabola is. So a parabola is the set of all points whose distance from a fixed point, called the focus, is equal to its distance from a fixed line, called the directrix. Now, what we'll do in order to graph one of these, let's say, for example, I create my focus, and we're going to make it right here, and then I'm going to make my line, this fixed line called the directrix, 4 units below it. Now, 2 units above the directrix and 2 units below the focus, we're going to have a point here, the one that is directly vertically below, and that's called the vertex. So that point that is vertically or horizontally, if we're looking at horizontal parabolas, right above the directrix and right below the focus, that's called our vertex. Now, what we're going to do is we're going to imagine that I'm going to go out on my focus. And remember, by definition, that distance away from my focus has to be the same distance as it is away from my directrix. So that's going to be another point on my parabola. As I move outward away from my focus, right, along these lines, okay, you can see, okay, that we're going to go upward in terms of the directrix as well. The directrix is going to get farther away as well. And so the vertex can also be thought of as the shortest distance between the focus and the directrix. Now, let's imagine that I go up and I'm like, okay, well, let's say I want that distance away from the directrix. Now, it's not exactly that amount. That's actually a smaller amount. So what we're going to need to do is we're going to need to move this further away. And so let's see. Let's say, for example, I get that distance right there. And maybe that's too far because now it's too far away from the focus. So we'll move it in just a little bit. And it seems like that's about right. So now there's another point on our parabola. So we go in and we connect all the points in this manner, and when we do that, what we get is we get our parabola. So all those points where we kind of like, okay, I'm going to construct a line from the directrix, and it's got a certain length, and then I'm going to find an equal length here from the focus, and wherever those two lines meet, that's going to be a point on my parabola. Now, what happens if we actually move the directrix and the focus closer together? Let's say, for example, I have my focus here, and now 2 units below, I draw my directrix. So now I imagine, okay, here's my vertex, because that's the one that's directly above the directrix and directly below the focus. And now let's say, for example, I draw something and I want it to be basically that far apart. And you can see, oh, look, well, there's my focus again. Well, now what about if I want one that's basically 2 units high in this case? Well, notice that distance here from the focus, that's gotten a lot larger. So what I'm going to do is I've got to bring it in. I've got to bring it in quite a bit, actually. And you can see there is where I'm going to have essentially my same size or my same distance. So what's going to happen here when we bring the focus closer together is we're going to get a narrower parabola. Not the greatest drawing in the world, but there we go. We get this narrower parabola. So when the focus and directrix are closer, narrower parabola. What about if we take it further apart? We should actually expect that our parabola is going to widen out. So it's going to widen out. We imagine, let's do that. Give us an example here, and we will draw our point there, and then there is our vertex right in between the two. And now let's imagine I want a point that is essentially just 1 unit higher up, just like I did before. 1 unit further above the directrix than the focus. And you can actually see, because of that distance, because of how great that distance is, it actually has to go quite a ways away from the focus. And that actually is what's going to end up widening out the parabola. now we can see we have a much wider parabola. So further apart, in terms of our directrix and our focus, that's going to be a wider parabola. What happens now if instead what I end up doing is I flip the focus and the directrix if I put them in different areas? So let's first put the directrix above the focus. So now say there's the focus, and so here's our vertex. And now if I imagine I want to go one step further away from the directrix, you can see that now we're actually going to be below the vertex, and consequently our parabola opens down. So when the focus is below the directrix, we get the parabola opening down. Now, what we can have here now is we can have also parabolas that open left and open right. So if instead of the directrix being a horizontal line, it's a vertical line. So let's say, for example, it's this vertical line, and we put the focus here, and there's our vertex. You can see now, say, for example, if we get something that's that long, we'll have to go a little further out. There's our distance. And you can kind of imagine that it's going to open. In this case, it's going to open to our right. To my right, excuse me, your left. If we switch that around, and instead we had directrix further to the negative than the focus, then what we would get is we would get something that would open then to the left, or my left. So the location of our focus and the location of our directrix actually is the thing that goes out and defines how it is that our parabola is going to look. When the focus and the directrix get closer together, what we end up with is we end up with parabolas that are in fact narrower. When they get further apart, we get them wider and change the location with respect to each other in terms of the directrix and the focus. And what you get is you get some that will open down, will open up, and some that will open left and some that will open right. Let's now find the equation for a parabola. So what we have now is we have our directrix down here, and at the top we'll have our focus. And we can actually assume we're going to do something without loss of generality, which means that we can actually talk about any kind of relationship between the focus and the directrix in this way from an algebraic standpoint and get the same equation basically. So we don't actually have to go through and do this equation over and over and over again. So we're going to keep it this way where the focus is on top, the directrix is on bottom, and the vertex is going to be in the middle, and we're going to have it at the point HK. Now, this line for the directrix then is going to be at the line y equals, and so it's going to be our y value, k, minus p. The y value in the vertex minus p. So that's actually that distance right there. That's going to be k minus p. And so that's the line of the directrix. That's its equation. And the focus, so that means that the focus is going to be at the point h, comma, k plus p. And that's where the focus is located. So that's going to actually set it up for us so that we can actually go find our equation. Now we're going to utilize the distance equation because we know that by definition, every point on this parabola is going to be the same distance away from the focus as it is from the directrix. So on the left-hand side, I'm going to put the focus equation. So I'm going to have the square root, and we have a general point x, and it's going to be x minus h squared plus, and it'll be the y point minus k plus p squared. And that's going to be my focus side. That's the distance from the focus to any point on the parabola. And that has to then equal the square root of, in this case, x, but the x value on the directrix can just be the same as the x value as it is on the parabola. So it's going to be x minus x squared plus, because you'll see, right, we can just move the x value on that directrix any way that we want. And so that'll give me x minus x squared, and then it'll be plus y minus, and now the equation for the directrix is k minus p squared. And so that's the equation, and not the k minus p squared, the whole thing is squared. And so that's our equation. Now what we're going to do is we're going to derive this general equation utilizing that equation. The next step is for us to actually just zero out this portion right here, the x minus x squared. Then I'll square both sides to get rid of the square roots. Then I'm going to go get all of my x's on one side and all of my y's on the other side by subtracting over this y minus k plus p squared portion, right? It's subtracted from both sides, and I get the x's on one side and the y's on the other. Then I'm going to go in, and I'm actually going to expand these out first by squaring y minus k minus p squared, right? And y minus k plus p squared. And so that's what this first row is right here. And then expanding out the 2y times k minus p, the k minus p squared, the 2y times k plus p, and the k plus p squared, so that I can actually go in and reduce down some of the algebra here. With that done, now what I'm going to do is I'm actually going to just subtract out the parts that are the same. So the y squareds are the same on both sides. Notice that these are minuses. So is the negative 2ky, the negative 2ky, the k squared, the p squared, and the p squared. And now you'll see that, excuse me, this one, by the way, should be a plus 2py because it's minus minus. So we'll have plus 2py, and then we'll have a minus and a minus 2py. So that's going to give me 4py. And then I'm going to have a negative 2pk and a negative times a positive 2pk, so a negative 2pk, so that's going to be minus 4pk. And so it actually kind of like cleans up very nicely. Then I'm going to go in and I'm going to factor out 4p from the right-hand side, and that's going to give me 4p times y minus k. I divide by 4p to both sides, and I get 1 over 4p times x minus h squared equals y minus k. And then I add over the k, and that gives me my standard form. The form that you're going to see quite often when you're going through and graphing parabolas or writing up parabolas. So this is going to be our standard form. What we're going to get here is that hk, that's the vertex. And that'll be very important for us as we graph. And p is the distance from the focus to the vertex. And that'll be our distance from the focus to the vertex. Remember, as p increases, we widen out. So we widen out the size of our parabola. So when p gets bigger, we have a wider parabola. And that's why, for example, when we have over here on this side, if we have like some kind of fraction in front of our x, what's going to happen with our parabola is our parabola gets wider and wider and wider. If on the other hand, p happened to have been a smaller number, right? Like say, for example, 1/2, this would have been 1 over 4 times 1/2. It'll end up being 1/2, and we actually get it narrower than our standard. Remember how I told you that without loss of generality, we could actually just assume that the focus was on the top and the directrix is on the bottom, and that's how we're going to go through and derive our equations. Well, if we just make some subtle changes, and we'll talk about those changes in just a second, we'll get all 4 of the different kinds of parabolas that we're going to be looking at. The first equation for a parabola is y equals 1 over 4p times x minus h squared plus k, and that's the one we saw. If p is greater than 0, then that parabola is going to open up. If p is less than 0, then the parabola is going to end up opening down. hk is going to be our vertex, and p is going to be the distance from our vertex to either the directrix or to the focus. Now, what if we want a left-right? Well, if we want a left-right, what's going to end up happening is that y is going to end up being squared. And so consequently, we'll get y squared, and then x is going to end up being a function of y. In this case, my directrix is going to end up being x equals h minus p. It's going to be a vertical line, and my focus is now going to be changing in terms of the horizontal instead of the vertical, so it'll be h plus p comma k. And if p is greater than 0, it opens towards the right, and if p is less than 0, then it's going to open towards the left. One other thing to notice is now we're going to be plus h and a minus k, and that's because, right, remember that k is the y value, all right, for the vertex, and h is the x value, and so consequently, when we switch x and y, we're going to end up getting the switch in terms of our vertex as well. Now, let's actually graph a parabola given the equation for the parabola in standard form. So the first thing that we're going to want to do is we're going to go through and find the focus, we're going to find the directrix, and we're going to graph the parabola. Generally, to graph a parabola, you're just going to go straight to number 3, but we do want to actually kind of like figure out how are we going to use this information to, in fact, find the focus and find the directrix. So the first thing that I'm going to notice is that my x value is the one that's squared. So what that tells me is that this opens up and down. So it's an up-down parabola. And in fact, because 1/2 is greater than 0, that means that p is going to end up being greater than 0, so it opens up. So that's going to give me some really good information about my parabola. Now, what I'm going to do is notice my vertex. And so if you remember, our general form is y equals 1 over 4p x minus h squared plus k. So if you notice here, h, we've got the minus sign here, and we have h. And so what that means is that h is going to end up equaling 3, and k is -1. So my vertex is going to end up being 3, -1. Now, in order to find my focus and find my directrix, what I'm going to need to do is I'm going to need to go out and find p. I find p because, remember, my focus is going to be h, comma, k plus p, and my directrix is going to end up being y equals k minus p. So I'm going to take 1 over 4p, and I'm going to let that equal 1/2. And then I'm going to solve for p. So what that gives me is that 4p equals 2, and so p ends up equaling 1/2. So my directrix, or excuse me, we'll start with my focus. My focus is going to be 3, comma, -1 plus 1/2. So that's going to be 3, comma, -1/2. And my directrix is going to end up being y equals, and so that's k, so that's -1 minus 1/2, so it's going to be -3/2. And there's my directrix. Now I'm going to go in, and I'm going to go and graph my parabola. I'll start out, I'm not actually going to generally draw my focus and my directrix unless I'm really required to. What I'm going to do is I'm going to start out with my vertex. So my vertex was 3, -1, so it's right here. I know that my parabola opens up, okay, because we did some early work there. And so consequently, what I'm going to do is I'm going to actually move over 1 in both directions. Move over 1 in both directions. So I'm going to imagine that I've just got, okay, I've got my table, I've got x and I've got y. And so if I take 3 and I subtract 1, that's going to be x is going to equal 2. Let's find out what y is. So it's going to be 2 minus 3, that's -1 squared. So that's 1 times 1/2 minus 1, and so that's going to be -1/2. So -2, -1/2, so we're going to put that right there. And now one of the things about the parabola is that it's actually symmetric about this line here, and this line is called the axis of symmetry. And that axis of symmetry is going to, in this case, because we have an up-down, is going to end up being x equals h. It's actually going to be the line directly through the vertex. So now that I have the 1 point for 2, -1/2, what I can do is I can actually draw another point directly across from 2, -1/2 to the other side, and then just basically connect the dots, give me a very rough shape for what my parabola is going to look like. And there we go. And that's a picture of my parabola. So all I really need to do is to draw the vertex, okay, and find 1 point, and then I draw another point that's directly adjacent from that point, and that gives me a rough graph of my parabola. Let's take a look at another example. Let's suppose that we have x equals 2 times y plus 2 squared plus 1. Now notice again that y is now the squared term, so this is going to open left and right, and we'll see that 2 is still positive, right? So p is going to be greater than 0, and so this is going to be opening to the right. We can see that's the case. A positive value, opening left and right, that means we're going to get an open right. Our vertex now, if you remember, this is going to be h, so this is going to be 1, comma, and this now is going to be k, so that's going to be -2. Remember, if it's inside of the parentheses, you've actually got to change the sign. You have to negate the sign, excuse me. So consequently, what that means is that we now need to go find p. So if you remember, 1 over 4p is going to end up equaling this value right here. It's going to equal 2. So we get 8p equals 1, and so p equals 1/8. So consequently, my directrix is now going to be x equals, so here's directrix. It'll be an x value because we're going right and left, and it's going to be x equals 1 minus 1/8, which equals 7/8. And my focus is now going to be 1 plus 1/8, so it'll be 9/8 comma negative 2, and so that'll be 9/8 comma negative 2. Remember, left and right, we're going to switch whether or not we're going to be adding to, x or the y value. It's just this opens right and left, we add to the x, and we keep the y values the same. Now we're going to go in and graph. We'll put in my vertex, negative 9/8, negative 2, so 9/8, there you go, and then negative 2, we'll go down 2. And now in this case, instead of us having our axis of symmetry being up down, because it's left right, my axis of symmetry is going to be this point, and it's going to be y equals h. Excuse me, it's not, it's y equals k. Sorry, y equals k, and that's my axis of symmetry. And now all I'm going to do is I'm going to go up by 1. So instead I'll use, say, for example, negative 1 in this case. So x equals 2 times negative 1 plus 2 squared plus 1. Okay, so this ends up equaling 2 plus 1, that ends up equaling 3. So x equals 3. So our y value, if we imagine our chart now, is going to have x and y. Y is going to be our independent variable. We put in negative 1, and we get out 3. So negative 1, and we end up at 3. And there we go. And utilizing our axis of symmetry, we can put one on the other side. There we go. And notice how much narrower this parabola actually is. This parabola is narrower because p is now small, right? P is equal to 1/8, all right? It's actually very close. Our directrix is right here. Our focus right above it. So that actually narrows out the parabola. So just to kind of review, what we want to do whenever we're going through and graphing is we're going to first figure out whether or not the parabola opens left and right, or up and down, whether or not it will open to the right, open to the left, open it up, open down. Then we find our vertex. That's the second step here. And then we have to go out and find P if we're going to actually find that focus in the directrix. If we're actually just going to go in and graph our parabola, what we can do is we can draw in our axis of symmetry, find one point on one side of the axis of symmetry, and create its mirror on the other side, and that'll actually allow us to graph out our parabolas. Now let's construct the equation of a parabola given a focus and directrix. The process is actually quite simple now that we have some general equations for the parabola. We have some basic understanding of how it is that they're graphed, and the relationship between the focus, the directrix, and the shape of the parabola and the vertex. So let's suppose that the equation for the focus of a parabola is negative 1, 3, and the equation for its directrix is y equals negative 2. Let's find the equation for the parabola. Now what we first want to notice is that our directrix, and that's the first thing I'm going to look at, is y equals negative 2. That means that my parabola is going to be up-down. It's not actually going to be a left-right, and that's because that's a horizontal line. Y equals negative 2 is a horizontal line. So consequently, my general formula is going to be y equals 1 over 4p times x minus h squared plus k. That's the one for the up-down. Now, what I need to get, I've got hk, that's my vertex. I want to find that. And I need to find p. Now, what we're going to do is we're going to remember that y equals k minus p. That's my directrix. And h comma k plus p, that's going to end up being my focus. And that's because we have that, again, that up-down. More appropriately, it's probably easiest to just think about the fact that the vertex is directly between, right, in this case, vertically, the focus of the directrix. The h remains exactly the same, okay? Notice h is the same. It's only the y that's going to change. So what I can do is I can find that midpoint on the y. So I'm going to take my focus point for my y, 3, minus, and the value for my directrix, 3 minus the negative 2, and I'm going to divide that by 2. right? So that's 5 over 2, that equals 2.5. That's halfway between the focus and the directrix. And that ends up equaling K. You can go in and do some algebra with it, but it's pretty much easiest to just think about the fact that it's halfway between the two. So what that gives me is that my vertex is going to end up being -1, 2.5. And there we go. Now I've got to figure out what P is. But P is not so hard, right? Because remember that K plus P, okay, is going to end up equaling, in this case, 3. So K was 2.5. I've got 2.5 plus P, and that equals 3, right? Because K is right here. And so consequently, P is going to end up equaling 0.5. All right? Notice this thing here, that's my vertex. All right? It's got K for its Y value. And then I'll just take my focus's value, which is K plus P, okay? And it equals 3. All right, so K plus P equals 3. I substitute in K, and then I go solve for P, and that gives me 0.5. Now all I got to do is just plug it in. So I get Y equals 1 over 4 times 0.5 times X minus a -1 squared plus 2.5. Simplifying, that gives me 1/2 X plus 1 squared plus 2.5. And that is the equation for my parabola. So go in, take a look, figure out whether or not we have an up-down to give you your general formula, or a left-right. Then compare, or well, basically what you're going to be doing is you'll find the midpoint between the Y values, in this case, for the focus and the directrix. If you happen to have a left-right, you're going to use the X values. And then we'll go in and that'll allow us to find the value for K. Once we've found the value for K, then all we've got to do is we've got to plug it in for the equation for the focus, right? We got K plus P, okay, equals, and you know what that Y value is for the focus, and then we'll plug in K. That gives me, in this case, we've got 2.5 plus P equals 3, so that gives me P equals 0.5. And that's how we find the equation for a parabola if we're given the focus and the directrix. Let's take a look at another example. Let's suppose that a parabola has a focus of 2, -2, and a directrix of x equals 6. What is going to be then the equation for the parabola? So if you remember, what we wanted to do first is determine whether or not this was a left-right parabola. And if you notice, the directrix x equals 6, that's going to end up being a vertical line, and so that tells me that my parabola is going to be left-right. So my general equation is going to be x equals 1 over 4p times y minus k squared plus h. So now that I figured that out, what I want to do now is to figure out what my vertex is. Again, since we're left-right, we're going to keep my k the same. So this is going to be h comma -2. That's going to end up being my vertex. And in order to find my vertex, what I'll do is I'm going to find the midpoint between 2 and 6. Well, what's right between 2 and 6? It's going to be 4. 4, -2. Now notice in this case, if we were to find the midpoint, we take 6 minus 2 divided by 2. That's going to be 4. And the reason why it's not our focus minus the directrix is because our directrix is actually now on the opposite side. All right, this one's actually going to be opening to the left. All right, so be careful with that in terms of the shorthand for the midpoint. Now, the next thing that we're going to do is we're going to go find P. So remember that the focus is K plus P, or excuse me, in this case, H plus P, and that's going to equal the H value for your focus, so that's going to end up equaling 2. Now, H is 4, so we got 4 plus P equals 2, so P is going to end up equaling -2. And that gives me all the information that I'm going to need. So X is going to equal 1 over 4 times -2 times Y minus, in this case, the K is going to be -2 squared plus 4. So X equals -1/8 Y plus 2 squared plus 4. And that gives me the equation for the parabola when I'm given the focus and the directrix. So what did we discuss in the lecture? 1, what is a parabola? Remember, it's defined as the set of all points that are equidistant from our focus and our directrix. 2, what is the equation for a parabola? How is it that we actually derived our equation for the parabola given that definition from the focus and the directrix? Then how do I find the focus, the directrix, and graph the parabola if I'm given an equation? Kind of put these ideas together. And then how do I find the equation for the parabola given the focus and the directrix? Allowing us to kind of switch that idea. So this completes this basic lecture. This is Dr. George Sweeney, and I want to thank you for watching my video. If you found it helpful and you liked it, go ahead and click the thumbs up. If you want more of these videos and you want to get my updates, please click subscribe. If you have any questions or you just want to say how much you really enjoyed the video, go ahead and leave some comments. I do read and respond to the comments.